Ladies and gentlemen, I'm glad and humbled and excited to be here this afternoon to share our vision, Ankr's vision, a distributed cloud computing platform built on trusted hardware. So my name is Ryan Fang, and I am the COO, co-founder, and very interestingly, I am personally the very first investor to the Ankr network project. As the only non-technical person out of the original 7-people team of Ankr, I guess I have to have a bit more titles so that people think I'm relevant. So a bit of a background about how we get started. So Mike, maybe you guys know this. I'm a very young guy. My co-founder and I, 2 of the 3 co-founders, we just graduated from UC Berkeley last year. And so the CEO, which is Chandler, he is currently in another conference in Korea. Back in 2014, he was already very interested in blockchain and the idea of Internet of Value. And he said, Ryan, you should probably buy some Bitcoin. And back then, I'm more of a finance background guy, and I thought, it's kind of bizarre to me back then. But obviously, after he explained to me the idea, how all things run, with a decentralized model, it started to make sense to me. And in 2014, I bought 20 Bitcoin, and Chandler bought 2, and that was the original sort of funding of the company. And we started back in last November, and Chandler got his boss out of Amazon AWS, who was one of the funding engineer of EC2. Obviously EC2 right now is a huge business unit of AWS, and got his super manager out of his job, and he's currently our CTO, Stanley Wu. And I'm a bit of a finance background, and Song Liu was our Force guy, Force core member, had a long experience in Palo Alto Network as well as Gigmom. Now, obviously, we have a bit more team member along the way after we finished our private run in June. We largely, thank our investor, lead investor being Pantera, NGC, as well as DHVC. One advisor I would like to talk about, which helped us tremendously along the way and will really sort of start today's main material or content of my little keynote, is Professor Anderson. So Professor Anderson is a professor out of UC Berkeley, and back in 1998, he was really the very first person, along with various other scientists, started the idea or created the genesis of distributed cloud computing. So back then, Professor Anderson, along with many other scientists, are interested in search for extraterrestrial life, finding aliens. Are there aliens? Please give me a raise of a hand. If you think there's aliens. Cool. Me too. I think so. So I actually, I'm actually on the BOINC network and contributing, on the SETI at Home project, contributing the sort of a computational resources to essentially analyze graphs that's taken by telescope and to find aliens, right? Now, the problem they initially faced was the fact that there was simply not enough computational resources. One graph, you can calculate it. 2 graphs you can, but how about thousands, even millions of graphs out there? Now, so they started a project called SETI at Home, and later on a more general purposed distributed computing platform called BOINC. But one thing to note, 20 years, it's all volunteer-based. You contribute, and you contribute to scientific researches, all kinds of projects, scientific projects mainly, and you don't really get reward. Though it's a great thing, and we certainly encourage it, but you don't get paid, pretty much. So an interesting demographic chart that Professor Anderson shared with us is that 95% of BOINC users are in North America or Western Europe, and 90% of BOINC users are male of 35 to 50-year-old, with a strong IT background, the geeks, who thought, obviously we really appreciate them, who thought it's very interesting and large beneficial to the society to contribute their computational resources for large projects like searching aliens. And they all have relatively high income, so then they do it on volunteer base. Now this is an interesting graph. I like everyone to look at sort of the right-hand side of the PowerPoint. The leaderboard. This is the true leaderboard of the Boeing project. So people are incentivized by what's exactly their total credit, the total Boeing credit. So the guy who actually got the most credit, he joined the network. There's a small mistake. He joined the network in 1999, and if we estimate how much computational resources this particular guy, or this node, in the blockchain sense, has contributed $4.4 million worth of cloud computing resources. And that was the first guy. There's a lot of people on the network. The whole Boeing project have over 300K users, and an active user around 100K. Now, why Boeing isn't in everyone's life yet? I maybe want another sort of show of hand. Anyone here has participated in Boeing in volunteer computing before? One. So could you tell us your name? Long time ago, right? So when you first participated, you didn't get paid a penny, right? It was a cool thing to do, and it was nice to contribute, right? So given that, obviously there's a lot of people, and I believe in the tech industry and investing industry. Only one show of hand, only one guy, thank you, participated in it. One reason it's not in everybody's life. 4 reasons actually, sorry. Privacy, redundancy, complexity, and incentive. Very easy to understand. Incentive, you contribute, it's volunteer thing, you don't get paid. Redundancy, obviously, when we trusting centralized cloud, when we are really trusting them is trusting they are executing the work that I give, let's say AWS or Google Cloud or Microsoft Azure to do. They will execute it. They will do your job. So that's what we are trusting the centralized, cloud service. But in decentralized way, it has to be, multiple, there has to be redundancies. You have to have multiple nodes, multiple computers across the globe to do the same job. Let's say 10, 15, even more to verify it. And it's extremely complex, and even, to be frank, for a guy like me who doesn't necessarily have a computer science background, a statistics major, though I can code R, it's rather hard for me to set it up. And it has only been so far for scientific uses and not for enterprises uses. Why? Because if you run your work on other people's computer, other people, as of now, in theory, can see what you are giving them to run. So there's no privacy. So no companies will actually do this, because all of their data, or all of their important money matter computations can be seen by other people. Obviously, it's not a preferable solution. Now, introduce Ankr, how we are going to bring the next generation of distributed cloud computing, or so the idea of decentralized cloud, the internet computer, to life. So 4 main place that we will improve on existing distributed or volunteer computing. A is financial incentive. I think this is the most easy thing to explain. Basically, there is a network token. Ankr token is going to be a network token. People participate. Whoever do the job will get paid by whoever tell them to do the job, right? And reduce redundancy. This is the main part of the technology and of our innovation. In 2016 or late 2015, Intel introduced Intel SGX, essentially, a TE environment, trusted hardware. The idea is code that's executed on the hardware enclave. The computer only cannot view it. It's all encrypted, and there's even you destroy the chip, you cannot see what's running. And so thus solve the large data privacy issue, and also solve the large redundancy issue. Why? Because the fact that the hardware enclave essentially can acting as a proctor to see if the work is executed already in the enclave. Now that you don't need 10 nodes to do the same thing. you have the enclave to tell you, look, we proves that it was executed. And it's going to be a platform for you. It's going to be a general purpose platform that everyone can use. You don't have to be a geek. You don't have to know so much about computer science. It's going to be an easy environment to set up for everyone in the world. Now, yeah, I think this graph shows, and this infograph shows a sort of idea of what is proof of use for work and how proof of use for work essentially enables distributed cloud computing. So basically, we all know proof of work here. Simple logic. Everyone, let's say there are 100 nodes. 100 nodes are all doing the hash calculation. Basically, trying passwords, right? Basically, trying passwords. Now, the first one got it right, you get a reward, right? Now, differently, and everybody is calculating the exact same work and not useful. So in the proof of useful work world, what happens is that your useful work, which is provided by useful work client, will be run on hardware enclave, and trusted hardware will proves that the work is executed, so that people will get reward. And at the same time, taking into account your CPU instruction numbers, as well as your CPU age and various other parameters, the protocol or the consensus will essentially give out a mining reward through a some process. Now, a simpler way of explaining it, let's say the consensus mechanism of proof of work is a professor, only one kid gets the reward, only one student gets the reward, everyone else is wasting their time. Now, a proof of useful work, here you can see, so the enterprises, they will essentially pay whoever is doing their job, Ankr token. And the consensus mechanism, will reward, will give out essentially the mining reward for the block generator. Now, I'm a business person, and I'm all about valuation and profit and margins and etc. AWS being the new lover, of Wall Street. Everyone thinks AWS is the most valuable business unit in the world because of three things. It's a traditional cloud, lucrative business with high barrier to entry, very, very high infrastructure cost. So far, only large tech giants are able to play this game. Google, Microsoft, Amazon, in China, it's Tencent and Alibaba. And for Amazon Web Service, last year was over 25% of operating margin, which is tremendous in any tech company. And obviously high human capital costs. We joke about this with our CTO, who was a prior employee, of AWS. They really pay Stanley a whole lot every year. So because it supports a variety of functionalities, what we are focusing on the computation, on what EC2 does basically, on the sort of bag of tasks. We're not already doing the hosting web service and etc. Well, obviously in the future we can go that direction, but as of now, it's mainly computational focused, sort of bag of tasks that we are doing. Now, market size, obviously we can see it's all growing at a very fast rate, the whole cloud computing market, and this is a very tremendous chart of AWS. The CAGR of AWS revenue is 55% of CAGR, and the CAGR of the operating profit is 105% every year over the last, over the last 4 years. So that is the pie that a decentralized economy can divide. If today you tell me, let's say right now you want to decentralize Uber, in my opinion, at this moment of time, it's hard to do, right? Because Uber itself, as of now, does not profit. It doesn't make money. So there's no pie to be shared, no pie to be cut. And in fact, they've burned so much money in the past, billions of dollars. And a decentralized model, well, I certainly think it's going to be the future, but it's very hard to achieve at this moment. But if you think about cloud computing, especially the one with computation focus, there is a big pie. There's a big pie to be shared, and there's a lot cost could be taken away. So this is sort of a trend of the chip makers all moving towards TEE. So as of now, our prototype, our runnable prototype or demo, is built on Intel SGX, which we think is the most business-ready TEE out there. But the industry is moving this direction. Back in 2014, ARM has their trust zone. 15, it's Intel's SGX. NVIDIA is going to have TEE on GPUs, and AMD as well. And now we have new generation of SGX. So our positioning or Ankr's vision, or what we're trying to do, is we want to utilize and leverage existing hardware solutions, existing hardware infrastructures. The same thing that I understand there are a lot of distributed cloud computing projects out there. Some with very high valuation, some with lower valuation. Let's say like us, sort of a little bit newer project. But basically, let me do an analogy. You can light a fire in two ways. First way is you use your match to use a very artful way to light a fire, right? Or you can probably use a lighter, which is readily available everywhere else. Though people say, are we trusting Intel? Are we trusting chip makers? But we think, from a business sense, in the long run, this is where the chip makers are going, and this is what we think is the future of blockchain. This sort of a combination of software solution and hardware solution. And as I have spoken before, the token gives you the incentive, and trusted hardware give you the data privacy, as well as essentially the attestation, which will reduce the redundancy. Now, we've shared many things to end today's little keynote. We've shared many things. We've shared cars with Uber. We've shared houses with Airbnb. In China, you can share bikes. In San Francisco, where our team is based, that we're based in the Silicon Valley. In San Francisco, you can share scooters nowadays. But what we think is the largest potential waste in 21st century is going to be your idle computational resources. I'm sure right now your laptop or your desktop at home is not running. And think about last time you throw your computer away when the CPU is completely fine, when everything is runnable. None of those resources were truly fully utilized. What we hope to do is to utilize those resources and potentially have people all across the globe to utilize them, to have even the idea of universal basic income. As long as you have a CPU, as long as you have your personal computer, you can make money out of the enterprises directly paying you. So that's our vision, and that's what Ankr do. And lastly, we're gonna have our public sale beginning of August, end of July. Please stay tuned, and thank you very much.